Hey, mathematicians. Today we're going to be talking about systems of equations and what they are and how to solve them. There's 3 different ways that we're going to explore solving them. The first one is by graphing. So let's talk about, first of all, what is a system of equation? A system of equation is 2 or more linear equations. And so the solution to the system is the point where the 2 lines intersect. So yesterday you talked about, or you reviewed graphing. And so today we're going to utilize that skill, and then we're going to look to see where the 2 lines intersect. And where they intersect is going to be considered their solution. The point will be written as an ordered pair. All right, so first of all, let's just check to see if something's a solution. And by the way, this is a really good strategy if you have a multiple choice question. If you're like, oh, I forgot how to solve a system, you can just check the answer. And by that, we want to know if I put -2 in for x and -4 in for y, does that work? Is -4 the same as 2 times -2? And we get that it is the same. Now, the issue is it has to be the same for both of them. And so is 4 times -2 minus -4 the same as -4? Is -8 plus 4 the same as -4? And because it is, because both of these come out to be identical, then what we can say is it is a solution. It works. All right. When we look at the other one, is 1 plus 3 times -2 the same as 7? Is 1 plus -6 the same as 7? And the answer is it is not. And because it's not a solution, it is not a solution for the system. Okay, so that's checking the solution. And so when you check for a solution, it's a good test-taking strategy to use. Okay, you just go back in. Does it work? Yes or no? All right, now, when you have a system of equations, you can have where they intersect at exactly 1 point. All right, you can have infinitely many solutions, which means that the line is the exact same. Both lines, when you graph them, are on top of each other. That's called an identity. It means that there's infinitely many solutions. Or you can have no solution. And what that means is that the 2 lines are parallel. They never intersect. To have a solution, they have to intersect or be on top of each other. So you have exactly 1 solution, you have infinitely many solutions, or you have no solution. Those are your possibilities, meaning the lines intersect, the lines are on top of each other, or the lines are parallel. So that's what we're looking at in terms of possible solutions. So what we're going to do is graph this solution, utilizing your skills that you talked about on the first section, and then we're going to see where they intersect. So y equals -3. That's going to be right here. It crosses the y-axis at -3. It's horizontal. And then y equals x minus 3. We're going to start here. And I'm going to graph it. I rise 1, run 1, rise 1, run 1, rise 1, run 1. And I've got my line drawn. Okay. Where these 2 lines intersect, that's my solution. And when I write my solution down, I write it as an ordered pair. 0, -3. I write it down as 0, -3. Graph. So I graphed my 2 equations. I found where they intersected. Here is the answer. They intersect at 0, -3. Okay. Let's try another one. This first one is written in standard form. You have a couple options. You can graph it using the intercepts. So if x is 0, what is y? If y is 0, what is x? Okay. So if x is 0, y is 11, because 3 times 0 plus y equals 11. So y equals 11. Or we can take 3x plus 0 equals 11. 3x equals 11. X equals 11 thirds. Okay, so 1, 2, 3.5. Oops, that's not quite right. 3 1/3, 1, 2, 3 goes about here. And then y is 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is up here. So this first one, I'm going to graph see if that works. Nope, let's try it again. Sometimes when I draw my line, it doesn't exactly go through where I want it to go through. So it makes it a little bit harder, but I'm going to try. One more time. Something's just not given here. There we go. Now what I'm going to do is graph the other one. And again, I can use standard form if I want to. So if x is 0, what is y? If y is 0, what is x? So 0 minus 2y equals 6. Negative 2y equals 6. Y equals negative 3. So 0, negative 3 is one of my points. And then if I have x minus 2y equals 6, so y is 0. Let's put 0 in there. So x equals 6. 1, 2, 3, 4, 5, 6. And I'm going to draw my line through here. All right, so I have my two lines drawn. The intersection point is right there, and that's 4, negative 1. So the answer is 4, negative 1. 4, negative 1. All right, let's try a couple more here. Graph the system, determine the number of solutions it has. If it has only one solution, name it. So let's take a look. Again, both of these are in standard form. Some of you might be more comfortable rewriting it in slope-intercept form. Let me try showing you that one as a reminder. So y is equal to negative 2x plus 2. So the 2 tells me I begin here. The negative 2 is my slope. I go down 2 over 1, down 2 over 1, down 2 over 1. And that can be my graph. All right. There it is. Okay. And then I can do the other one. I can do y plus 2x equals 9. I'll subtract 2x. So I'll get that y is equal to negative 2x plus 9. I cross at the 9, which is right up here. And I go down 2 over 1. Down, oops, down. Looks like I messed up a little bit. Let's try this again. Down 2 over 1, down 2 over 1, down 2 over 1. And what I'm noticing, whoops, let's back that up. One more try. Third time's a charm. We got it? Yes. What we're noticing is that these two lines are parallel. So that means that there are no solutions. And another hint to this would have been that their slopes are identical. And if they have the same slope, they're parallel. The lines are parallel. They have no solutions. So we would just say no solution. There's just nowhere where it crosses. All right, one more, and then we're going to give you some time to work and practice this. So we're going to graph the system and determine the number of solutions it has. If it has one, we're going to name it. That means if it intersects, we're going to say where it intersects. So with this first one, I'm going to use the intercepts to solve. So if x is 0, what is y? If y is 0, what is x? All right, so 0 minus y equals 2. Negative y equals 2, y equals negative 2. All right, so that's one spot where this crosses. And then x, x minus 0 equals 2, so x equals 2. All right, so I'm going to graph it out this way. Okay. And then I'm going to go ahead and graph the other one. I'm going to shrink this down a little bit. All right, here we go. 3y plus 2x equals 9. So I'm going to do if x is 0, what is y? If y is 0, what is x? So 3 times y equals 9. Y equals 3. So it crosses the y-axis at 3. And then with the other one, I'm going to put 0 in for y. So 3 times 0 plus 2x equals 9. 2x equals 9, divide by 2, x equals 4.5, 1, 2, 3, 4.5. So I'll draw a line through those two. All right, and here's where they intersect. So my solution is going to be 1, 2, 3, 1. Whoops. They intersect at 3, 1. 3, 1. All right, so on your assignment today, you're going to be graphing, you're going to be finding where they intersect. Maybe they're never going to intersect. That means there's no solution. Maybe they're going to be the exact same line. Then that means there's infinitely many solutions. Reach out with any questions, kiddos. Have a fantastic day.